So in this class, we will discuss about the independent events. So what are independent events in probability? We will be seeing right now. So these independent events are also important in probability and statistics part. So questions may come from this topic also. So we'll discuss what are independent events. We will see the formula and we'll see some generalized examples. So with that examples, we will come to know what is independent event and how can we solve those such a type of problems by using these formulas. So what is independent event means the two events are said to be independent. It means the two events are said to be independent events if the outcome of an event does not affect the outcome of another. It means suppose there are two events. So even means set, already we know that event is a set of possible outcome. Set of outcomes in an experiment that is called an event. So suppose there are two events from a random experiment. So the event one is if I flip a coin in the air and getting the outcome as a head, this is the event one. And again if we flip the coin, but this time instead of getting head, we got the tail. So this is the second event. It means these two cases are independent of each other because getting tail and head are independent of each other because there is no dependence between the two events. So such a type of events are called independent events. So and also this getting a head. Uh, Suppose in the first event we got head. In the second event, I got tail. So this tail, this in the second event, getting a tail does not affecting the first event getting a head. It means the second event is not affecting the outcome of another event. It means suppose if you consider two events, one event is not affecting the another event. It means it is not affecting the outcome of another event. It means whatever the outcome that is getting in another event, it is not getting affected through this outcome of one event. So this is called independent event. Or also we can say that if one event does not influence the probability of another event, it is called independent event. Suppose there are two events. One event is not influencing the probability of another event. So that is also called as an independent event. So that is what we are saying. So we'll see some examples. And also see here, two events A and B are said to be independent if. So suppose there are two events A and B. So this A and B are two events. When can we say this A and B are independent of each other means P of A intersection B equal to P of A into P of B. It means this it means this one of the event is not affecting the outcome of another event. So that's why it is called independent of each other. So this is called independent event. So what is the formula for independent event? Is P of A intersection B equal to P of A into P of B. It means that the both events happen is called the product of their individual probabilities. So we can say this as the probability of happening the both the events is equal to the product of individual probabilities. So this is called independent event. So this P of A and P of B are independent of each other. So um, and also we can see this P of A given B equal to P of A intersection B into P of B. So where P of B is not equal to 0. So we can write like this also. Next one. If the given two events A and B are independent, then P of A given B equal to P of A or P of B given P of B given A equal to P of B. Suppose there are two events A and B. Suppose those two events are independent of each other. It means the outcome of the event A is not affecting the outcome of event B. Then we can say that P of A given B equal to P of A because A is not affecting the outcome of B. That's why P of A given B is written as P of A. Or we can write it as P of B given A equal to P of B for any independent type of event B. So what is the reason behind this? P of A intersection B equal to P of B into P of A for any independent type of events. So now we will see some examples. So with that examples, we'll come to know how can we solve the problems of independent events. So suppose first example, Joseph and David are playing with cars in a park. There are 52 cars. It means already we know about the cars. So in the cars, so how many cars will be there? Totally 52 cars will be there. So with that 52 cars, Joseph and David are playing with that cars and in a pair. So with this pair, they are playing with the cars. And Joseph drew a card at random with replacement. It means Joseph has drawn one card. Randomly, he has drawn one card with a replacement. It means after picking a card, he is replacing that position with another card. So that is the replacement. And after that, he asked David, what is the probability of drawing? And after that, he asked David, what is the probability of drawing queen followed by king? So after drawing a card with a replacement, Joseph asked the David, what is the probability of drawing a king followed by a queen? So after drawing a king, what is the probability of drawing a queen? It means after picking a king card, what is the probability of drawing a queen card? It means both are independent of each other. It may, how we can say here if they have given independent condition. What is the first event? Suppose if we take drawing a queen in the first condition. So what is the probability of drawing a king? That is how many queens are there? Totally four queens are there out of 52. That is 4 by 52. Next one. Drawing a king in the second condition after king with replacement. So after um, it means we are drawing a king in the second condition. It means we are drawing a card in the second condition after a queen with replacement. It means we are replacing that queen with another one. It means again we will be containing four cards out of 52. That's why it is 4 by 52. So what is the what is the question that he is asking? What is the probability of drawing a queen followed by a king? So the probability of drawing a queen followed by a king is equal to 4 by 52 into 4 by 52. That is 1 by 169. So these two events are independent of each other because drawing a queen and drawing a king are independent of each other because so drawing a queen is not affecting the outcome of the drawing a king. So that's why both are independent of each other. So like that we can be able to solve such a type of questions. So we'll see the next question. Next one. A juggler has 7 red, 5 green, and four blue bars. Suppose there is a juggler. He is having 7 red balls, 5 green balls, and 4 blue balls. So during his turn, it means he is doing one stunt. During his turn, he accidentally drop a ball and then picks it up. It means he is doing his stunt. Accidentally, what he done means he dropped a ball. So whatever the ball that he is having, he dropped the ball and again he picked it up. So like that he is continuing ball by ball. It means another ball pass. Until the another ball comes, he is continuing like that. So what is the probability? So what is the probability that the first ball that was dropped is blue and the second ball is green? Suppose he is dropping ball number of times. So suppose the first ball dropped is blue and so whatever they are asking is what is the probability that the first ball drop is blue and second ball is green. It means he is dropped balls independently. It means first time he drew the ball and he dropped that ball and that is the blue color. And second time he took another color and he dropped it. The second ball color is green. So here we can able to see that these two events are independent of each other because drawing a green ball for the second time is not affected the event of the first ball that is dropped is blue. So these two events are not affecting each other. So that's why this and also they are not depending on each other. That's why they are independent of each other. So now we will take. So totally how many balls are there? 7 red, 7 plus 5 green, 12 plus 4, 16. Totally there are 16 balls. So the sample space size is 16. Next one. First we have to see the first ball that was dropped is blue. So we can able to see that the probability that the first ball is blue. So how many blue balls are there? Four blue balls are. So out of 16 we are taking blue balls. So how many blue balls are there? Four blue balls are there. So 4 by 16. So that is the probability that the first ball is blue. Next one. Probability that the second ball is green. It means already here the juggler is having 7 red balls, 5 green balls, and 4 blue balls. It means he is having it means he's having different kinds of balls and they are not dependent of each other because different balls are containing in different boxes. So that's why they are independent of each other. So when in the second run, the probability that the second ball is green. So whenever he took the ball and he dropped it, that is green color. What is the probability? How many green balls are there? Second ball is green. It means it is 4 by 16. So why 4 by 16 means second ball is green means here they are not asking about the with replacement. So that we have to consider it as without replacement. So second ball is green means first ball will be blue ball. So how many green balls are there? Five green balls. Out of that, they are asking second ball. So already one ball has so out of five, one has got. How many are left? Four. So among four, they are asking the probability that the second ball is green means 4 by 16. Next one. So what is the question they are asking? The probability that the ball was dropped is blue and the second ball is green. It means that probability of blue and green. It means P of B intersection G. So according to the formula, already we know that P of A intersection B equal to P of A into P of B. So here what is P of blue and green equal to P of blue into P of green. So what is the probability of that the first ball is blue is 4 by 16 into next one. What is the probability that the second ball is green means it is also 4 by 16. Totally it is 1 by 16. So this is the final answer. Now see the third one. In a survey, a company found that 6 out of 10 people eat pizza. It means there is a company, and in that company there are 10 people. So they conducted a survey how many people are eating pizza from the 10 people. Out of 10 people, they have found that only 6 people are eating pizza. And if 3 people are chosen at random with replacement, and we are choosing 3 people with replacement, it means we are going to replace those 3 people by the another people. So, what is the probability that all 3 people eat pizza? So, suppose if you are choosing 3 people randomly with the replacement, they are asking about what is the probability that all 3 people eat pizza. So now we will see if 3 people are chosen at a random with a replacement who eat pizza, then probability of all eating pizza is. So suppose how many people are there? 10 people are there. Suppose they are taking 3 people randomly and they should eat pizza. So the probability of person one like pizza means 9 by 10 because out of 10 we are picking only one. It means uh, how many are left? Nine of them. Nine left. So 9 by 10. So next person, probability of person 2 likes pizza means 9 by 10. Because we are replacing, it means we are replacing that person with another person. Already in the question they have given, see, if 3 people are choosing at random with replacement. So that's why the replacement is done. So why it is 9 by 10 means how there are 10 people. We are choosing one person who eat pizza from them. It means already one person has there. Out of one person left, how many people are there? 9 by 10. So like that for person 3 also 9 by 10. It means they are asking about probability of person 1 and person 2 and person 3. It means already we know that P of A intersection B intersection C equal to P of A into P of B into P of C according to the um, independent event. So 9 by 10 into 9 by 10 into 9 by 10. So finally we got the solution as 729 by 1000. And also there are some important points are there. Please note that. Suppose mutually exclusive events are not independent because if one occurs, the other cannot. It means whatever the mutually exclusive events. What is the mutually exclusive event means? P of A intersection B equal to B 0. It means there are no common path between them. So they are not independent because if one occurs and other cannot. Because if one event occurs, the other cannot occur. So that's why they are not independent of each other. It means they are dependent of each other because while the second while one event is happening, the other event is depending on the second event. So that's why they are not independent of each other. And also more than two events can also be independent. Suppose not we cannot we cannot say only two independents are event, but we can also say that more than two events are independent. Suppose if you take three events or four events or five events, they can also be an independent. So and also see, but pairwise independence does not guarantee mutual independence. Suppose there are pairwise independence events are there. So those independent events does not guarantee mutual independence. It means it does not. What it will say is this pairwise independence is not guaranteeing the mutual independence. It means one event may not depend on another event. That is what it is saying. So we will see the next example. A six-faced dice are rolled and coin is tossed. Suppose a dice is rolled. For that, there are six faces having for that dice. Suppose we roll the dice and after that we tossed a coin. It means this dice and coins are independent of each other because whatever the output that is getting it from the dice, it is not going to affect the coin because they are independent. There is no relationship between the coin and dice because we are performing this experiment independently. So that's why from this example we have to understand like that. So determine the probability that a tail will appear on the face of the coin and a four on that side. Yes. So whenever we toss a coin, they are asking that the probability that a tail will appear on the face of the coin. So whenever you toss a coin, a tail will appear on the case and also four on the dice. So there is no relationship between this dice and coin. So that's why they are independent of each other. And this tail appearing on the dice will not affect on the outcome of the four appearing on the dice. So there are two events in that. So first of all, what we have to consider is tail appear on the face of the coins. So what is the probability that tail in the coin is 1 by 2 because probability of getting it is 1 by 2, probability of getting tail is 1 by 2. That's why probability tail in the coin is 1 by 2. So next one, probability of getting 4 on the face of a dice. So how many possibilities are there for getting 4 means 1 by 6 because there are 6. So 6 faces. So and 6 numbers. For every number, we are having only probability 1 by 6. So the probability of getting 4 on the face of dice is 1 by 6. And these two events are independent. But we can able to estimate the probability of two or more independent events by multiplying their probabilities. Even if you want to, even we can able to estimate the probability of two or more independent events. How means by multiplying their probabilities. So here 1 by 2 into 1 by 6 equal to 1 by 12, not 12. 1 by 2. 1 by 2 into 1 by 6 equal to 1 by 12. So this is the final solution for the given problem. Hope everyone understood. So see the next example. So a box contains four pink balls. Suppose we are containing a box. So a box containing four pink balls and five orange balls and six blue balls. Suppose we are having a box. In that box, we are containing separate four pink balls, five orange balls, and six blue balls. It means they are independent. It means they are not mixed with another ball. They are containing separately. So that's why the outcome of one ball does not affect the outcome of another ball. So these three events are also independent, like that we can able to understand. After that, see the question. Two balls are selected from the box. Suppose we are selecting two balls from the given box. It means we don't know what type of two balls. Suppose one ball is pink, one ball is orange, one ball is pink, one ball is blue. Suppose one ball is orange and one. Suppose one ball is pink. Suppose one ball is blue and one ball is pink. Like that, we don't know what are the two balls that we are selecting. And with replacement, it means we are replacing one ball. After picking one ball, we are replacing that ball with another ball. So that is what with replacement. So the question, see the question what they are asking. Determine the probability that both the chosen balls are orange. It means if we are selecting two balls, so they are asking the probability that both the chosen balls are orange. So whatever the balls that you are selecting, those two balls should be orange. It means we have to take two balls from the orange colored balls only. It means we are picking only from orange colored balls. It means they are not depending on pink balls and blue balls, independent of other two events. So that is this is independent event. So now we'll see a possibility. So probability of selecting both orange balls. So what is the how many total balls are there? 10, 15. So out of 15, what is the probability of selecting both orange balls is 5 by 15 into 5 by 15. 5 by 5 by 15 means we are having 5 orange balls out of 15. So they are asking the question only about the orange balls. That's why I took the orange balls. So first ball chosen orange is 5 by 15. Next ball chosen orange is also 5 by 15 because they are asking with replacement. Without replacement means 5 by 15 into 4 by 14 like that it will come. So after replacing also we are having 15 orange 15 total 15 balls and also we will be having 5 orange balls. Means we are replacing that ball with orange ball only. That's why they are independent of another balls. So 5 by 15 into 5 by 15 equal to 25 by 225. After solving that, after simplification, I got 1 by 9. So this is the problem. So next example. What is the probability of 3 heads in a row? Suppose we are tossing a coin. What is the probability of getting 3 heads? We know that for every toss we will get the sample outcome. So probability of getting head and tail is 1 by 2. That is 0.1. So probability of getting 3 hits in a row means continuously they are asking what is the probability of getting 3 hits in a row means continuously 3 hits means first of all what is the probability of getting in a single pass means 1 by 2. For a 3 times in a row means 1 by 2 into 1 by 2 into 1 by 2. So sorry, not 1 by 12, 1 by 2 into 1 by 2 into 1 by 2. That is 1 by 8. That equal to 1 by 8 equal to 0.125. That is the solution for the given example. So see the next question. So Amit and Kavya are playing cards. It means Amit and Kavya are two persons are there. They are playing with cards. So wherein Amit drew a card with replacement. So Amit, suppose among 52 cards, he drew a card with replacement. It means after picking a card, he is replacing that card with another card. It means before replacement and after replacement, there are equal number of cards, same number of cards are present. And also Kavya picked a card. Likewise, likewise, Kavya also picked a card like Amit. So they are asking the question, what is the probability of drawing a jack followed by a queen? So are asking from that card, they are picking the card with what is the probability of drawing a jack followed by a king. So after picking a jack, what is the probability of drawing a so after a queen, what is the probability of drawing a jack after picking a queen? It means they are both are independent of each other because jack is In another set, queen is another set. So there is no relation and there is no dependence between these two events. So these two will not affect each other. That's why these are two independent events. So as per the question, we have to take there are two events in that. We have to take what is the first event. It means probability of picking a jack in the first step. It means we are following two steps. From that two steps, what is the first step means probability of picking a jack in the first step. So how many jacks are there out of 52 cards? There are four jack cards are there. So out of 52, there we are picking four jack cards. So that's why 4 by 52. Next and next one. Next step is probability of picking a queen in the second step. It means we are picking a queen in the second move. So this event is not affecting from the second event. It means there is no dependence between the picking jack and queen because it is different from the another. So that's why these are independent features. How many queens are there in the pack of cards? There are four queens are there. So out of 52, we are picking probability of picking queen means 4 by 52. So what is the question means what is the probability that drawing a jack followed by a king means probability picking a jack and king. P of A intersection B. Already we know the formula P of intersection B. Whenever these two events are independent, it's P of A into P of B. That is 4 by 52 into 4 by 52. That equal to we got the answer as 1 by 169. So this is the solution for the given example. And also we will see some please wait. And also we will see some more examples. Wait, I am taking another slide. Now see the another question. Suppose we are containing three bags containing three red and two green balls. Suppose in three bags we are containing three red balls and two green balls and three red balls and five green balls and one red and four green balls. So for each bag we are containing three red balls, two green balls, three red balls, five green balls and one red and four green balls respectively. It means in bag one we contain three red balls and two green balls, and in bag two we are containing three red balls and five green balls, and in bag three we are containing one red ball and four green balls respectively. It means ball one, B1, B2, B3 are the three bags, and those three bags are independent of each other because they will not affect each other. So that's why they are independent. Suppose if we draw one ball from each bag, what is suppose if we want to suppose we are drawing a one ball from each bag. So B1, B2, B3 are the three bags. So from each bag we are drawing only one ball. So we don't know that what is the ball that we are drawing. So they are asking the question that what is the probability of getting a green, red, and green ball from first, second, and third bag respectively. So what is the question means? They are asking getting a green ball, red ball, and again green ball from first, second, and third one respectively. It means in the first bag we have to get green ball, and second bag we have to get red ball, and in third bag we have to get the again green ball. So we can able to write that as okay of G1 intersection R2 intersection G3. So these three events are independent of each other. So that we can write P of G1 into P of R2 into P of G3. So what is the probability of getting a green ball from the first bag means? So how many green balls are there? Two green balls. How many total how many total balls are there? Five. So 2 by 5 into. Next, what is the probability of getting a red ball from the second bag means how many red balls are there in the second bag? 3. 3 by how many balls are total balls are there in the second bag? 8 balls. 3 by 8 into. Next, probability of getting green ball from the third bag. It means in third bag, how many total balls are there? 5 balls. 5 balls are there. So how many from that how many green bars are there? Four green bars. So that's why 4 by 5. So 2 by 5 into 3 by 4 by 5 equal to 3 by 25. So these three events are independent of each other. So we have solved the first one. So we'll be seeing the next one. So what is the probability of getting two green and one red bar? It means there here there is order is not matter. They are asking two green ball and one red balls. It means we are having the possibilities like this. So we are having B1, B2, B3 B3 bags are like this. So in B1 bag we are containing three red balls and two green balls. In B2 balls we are containing three red balls and five green balls. And in B3 bag we are containing red ball and four green balls. So these are the total bags available for us. So they are asking two green balls and one red ball. So how can we choose this two green balls and one red ball? Means probability of getting green ball from first bag and green two from second ball and red ball from third ball. This is one combination. Another combination is G1 R2 G3. It means green ball from first bag, red ball from second bag, green ball from third bag. Or we can able to choose red ball from first ball, green ball from second ball, and green ball from third ball. These are the various combinations possible for getting picking two green ball and one red ball. It means we can able to whatever the order that doesn't matter, but there should be two green balls and one red ball. So these are the various combinations. So by solving this, I am by using this formula, two greens and one red. By using the, I am using this formula. Probability of G1 intersection G2 intersection R3 plus P of G1 intersection R2 intersection G3 plus P of R1 intersection G2 intersection G3. So these are so for these three combinations, I am using this formula. So already we know that the independent event for P of A intersection B intersection C that equal to P of A into P of D into P of C. According to the independent event, this is the formula for that. So for P of G1 intersection G2 intersection R3, the formula is for probability of G1 into probability of G2 into probability of R3 plus next for P of G1 intersection R2 intersection G3, that is P of G1 into probability of R2 into probability of G3 plus next P of R1 intersection G2 intersection G3 is probability of R1 into probability of G2 into probability of G3. So by solving this question, I'll get the answer as 47 by 100. So from this we can able to solve what is the probability of green ball from the first bag and like that. You can able to solve and get the simplification. After that you will get the 47 by 100 as the final solution. So next example. So next what they are asking is a card is selected at random from an ordinary of 52 playing cards. So there are 52 playing cards are there. Out of them they are selecting one card randomly. So if A is the event, suppose there are two events, from that A is the event that the selected card is an ace. So A is A is the event which we select the ace card, and another event is H is the another event which we select the card is heart. So they are asking about are A and ace cards and H are independent of each other? They are asking. Now we will see there are two events. So first event is A. So the probability of getting an ace. So how many aces are there out of 52? Four aces are there. Next event. So the probability of getting an ace from the cards is 4 by 52. That equal to 1 by 13. So next one. What is the event? What is the next event? Getting an event from the cards. So that is hearts. It means getting a heart from the cards. So how many hearts are there from 52 cards? There are 13 hearts are there. So the probability of getting heart from the cards is 13 by 52 equal to 1 by 4. Now what they are asking is whether these two events are independent of each other. So according to the independent event, we have to solve the probability of A intersection B. It means getting A's of hearts. It means from that hearts we are there have to find getting A's. It means A intersection H. So according to the formula, we know that P of A intersection H equal to 1 by 52 because P of A into P of H equal to 1 by 13 into 1 by 4. So that is 1 by 2. So those two events are independent of each other because they have to satisfy this condition because P of A intersection H equal to P of A into P of H. So whatever the value that is right side is getting, same value you have to get from the left side also. So LHS equal to RHS. So the condition is satisfied. So these two events are independent of each other. So this is the final solution for the given problem. So see the next one. So these are the properties. So see the properties. Suppose A and B are independent events, then A and B complement are also independent. Suppose we are taking two events A and B. If those events are independent, then A and B are independent, then A and B complementary are also independent. Next, A complement and B are also independent. Next, A complement and B complement are also independent. Now we will see the proof. So what they are saying, if A and B are independent events, then A intersection B complement are also independent. So we will see P of A intersection B complementary equal to. So P of A, we can able to write this P of A intersection B complementary as P of A minus P of A intersection B. So that equal to P of A minus. So according to the independent events, P of A intersection B equal to P of A into P of B. So I am writing P of A into P of B. So from that from this I am taking P of A common. So whenever I take this P of A common, I am getting P of A, 1 minus P of B. So P of A into, how can we write this 1 minus P of B means P of B complementary. So P of B complementary equals 1 minus P of B. So from this place, I am replacing P of B complementary. So P of A intersection B complementary equal to P of A into PB complementary. So this is the proof for the P of A intersection B is also independent event. So that A and from this we can also prove that we proved that A and B complementary are independent event. So next one, P of A complementary intersection. Third one. Likewise, we can also prove P of A complementary from the first example. I am solving the third example. P of A complementary intersection B complementary. It means according to the De Morgan's law, I can write this as P of A union B whole complementary. So according to the axioms of probability, I can able to write this probability of A intersection A union B whole complementary as 1 minus P of A union B. 1 minus. According to the probability axioms, how can we write this P of A union B means P of A plus P of B minus P of A intersection B. So this is from inclusive and exclusive events. So uh, apply this minus for all the events. 1 minus P of A minus P of B plus, already we know the P of A intersection B according to independent events P of A into P of B. So that's why I am writing it as P of A into P of B. So from this I am writing 1 minus P of A into 1 minus P of B. After solving this, I am getting P of I can able to write this 1 minus P of A as P of A complementary, and I can able to write this 1 minus P of B as P of B complementary. So from this proof, I already proved this A compl from this proof, we can able to understand that if A and B are independent events, then A complementary and B complementary are also independent. So remember those things. So see the another example. If two people A and B are interviewing for a job, suppose there are two people A and B, so they are interviewing. They are interviewing for the job purpose, and the probability of their selection is P of A equal to 1/2. It means the probability of selecting the first person is 1/2, and the probability of selecting the another person is 1/3. So what is the probability that both of them are selected? So it means that they are asking what is the probability of getting both of them are selected. It means P of A intersection B. So these two events are independent of each other because they are interviewing separately. So he may select or may not select. Another person may select or not select. So these two events are independent of each other. Suppose person A is not selected, but there is no problem. There is no guarantee that he will not select according. He will not select. Definitely he may success. Suppose first person is selected for the interview. We cannot guarantee that the second person cannot select. So he may also select. So that's why there is no dependent between the first person and second person. So that's why they are independent of each other. So both of them selector means P of A intersection B according to the independent events. P of A into P of B that equal to 1 by 2 into 1 by 3 that equal to 1 by 6. So this is the probability of them both are selected. So next one, exactly only one of them is selected. It means only one is selected, another is not selected. It means in the what are the possibilities means A is selected and B is not selected, or B is selected and E is not selected. So that is what we are waiting. So P of A intersection B. It means A is selected but B is not selected, or A is not selected but B is selected. So how can I write this P of A intersection B one complementary according to the multiplication? Sorry, dependent variables P of A into P of B bar plus how according to my independent event I can write this P of A bar intersection B as P of A bar into P of B. So what is the value of P of A? P of A is 1 by 2. What is the value of P bar? P bar means 1 minus P of B. It means 1 minus 1 by 3, 2 by 3 plus. What is the value of P of A bar? 1 minus P of A. It means 1 minus 1 by 2. That is 1 by 2 into. What is the value of P of B? P of B 1 by 3. That equal to 1, 2 by 6 plus 1 by 6. That equal to 3 by 6. That equal to 1 by 2. So this is the probability that exactly one of them is selected for the interview. So this is the independent event in the probability concept. Hope everyone understood and hope everyone clear about this. So, so I think hope everyone understood whatever that I taught. Hope everyone understood each and every problem that I taught in the video. So we'll see in the next session. So if any problems are remaining, I'll I will teach in the next lesson. I will upload in the next videos. So we'll see in the next video. Until then, bye bye. Thank you.